To error detection and correction. Chapter 6 covers that a lot. But the whole concept of that is that the very moment you start delving into digital transmission, then you have to figure out ways to handle error controls, detection of it and its correction. So in general, how to control some of these errors, so at least you can be able to address the high quality signal and higher data rates that you need. Channel access were also made dynamically and shared by users via time division, multiple access, or using code division multiple access. The first generation was using the frequency division multiple access, while the digital transmission were using time division. So that made it a lot more easier to dynamically share the channels for transmission. So that gave you more option for channel access as compared to your dynamic. So as compared to your first generation, where frequencies did not have time allocation to it, so you were limited in the number of channels that you could allocate for a transmission need. Okay, so two of the key uh, channel access mediums that were designed were the time division multiple access and the code division multiple access, which is CDMAs and then TDMAs. And to look into that, we have wireless multiple access method that we had where the three main one that we had, the frequency division multiple access, where a user channel is private, is of a private frequency, whereas the time division multiple access, a user's channel is within a specific frequency itself, but it only belongs to a user for a given time slot, and it can be repeated sequentially over a given period of time. On the other hand, within the code division multiple access, each user signal is in a continuous unique code pattern buried within a shared signal and then mingle with other users of code patterns. So within this case, you'd have a user code pattern is well known, and the presence or absence of their signal can be detected. Thus, convey information back and forth a lot easier. And so, in this sense, you're able to handle encryption models much more efficient to avoid eavesdropping, to and minimize unsecure transmission. So anyway, that was just to elaborate on these uh, channel access method that we had for wireless transmissions. We had the frequency division multiple access for analog, and these two were mostly the digital based transmission channel access modes that was implemented. Just wanted to cover that real quick, just giving a brief idea about that, so at least you know how they were able to handle encryption and improve uh, signal quality and also increase higher rates and also provide better encryption for the messages or transmissions with a given conversation, whether it's voice or data. Okay, so looking at code division, which is a huge part of global system for mobile services, which is GSM. Sorry, uh, let's look at the code division multiple access or CDMA and global system for mobile telecommunication or a GSM. These are both actually a major radio system used by cell phones or used by cellular networks. CDMA uses code division system with every transmission call data is well encoded with unique keys. Each cell is allocated frequency bandwidth and is split into two, half for reverse or half for forwarding, and you have direct sequence spread spectrum being allocated for the transmission. So it made it much more efficient in how transmissions were managed Most of the CDMAs were widely adapted within the US market and North American market to address transmission needs. So if you go to US, for instance, you notice that most of the cellular networks uses CDMAs, but I understand they've also migrated to GSM these days, mostly because GSM offers a different approach to cellular transmission that was highly standardized by ITU, the International Telecommunication Unit, and well researched and well documented. So it's now becoming the center of practically just about what cellular networks is all about these days, and it's well adapted across bigger regions, with the exception of the North American regions. Okay, so you could say that the CDMAs are more of North American, and then the GSM are basically the rest of the world, basically. So here is how a code division multiple access will look like and how they encrypt information using codes. So you have a medium of transmission that was provided, and users could share the entire medium based on the fact that it uses different codes. So at the receiving end, the code just, when it comes to the multiplexing, it makes it a lot easier for the end device to identify whether a particular signal belongs to them or not. It was easy to basically manage that because the codes that were embedded within the signal. That usually alleviates transmission interferences or signal challenges that happens within a given transmission. So it was quite helpful, I guess. If every transmission had its own code of transmission, of code of transmit information, then it was easy for the various units uh, to be able to modulate it and understand that, okay, this particular message belongs or signal belongs to me and this doesn't belong to me. So it was a lot easier for systems or base units to identify how to relay messages back and forth to from receivers and to from transmitters or transmitting mobile units or receiving mobile units, just based on the codes that were attached to the signal. So a good approach, good approach. And within this, you could share the medium. There was no interference. You could share the medium, like we pointed out earlier on. Signals could be shared. Okay, could be shared across a number of channels. Where is it shared? Where is that at? Yes, channels can be dynamically shared based on time division multiple access or the code division multiple access. So you could have multiple channels being transmitted over a given medium without any interferences or issues in terms of which message belongs to which mobile unit. And then when it comes to the GSM, which uses time division multiple access, which is currently a big part of current mobile technologies, every transmission voice call needs to be transformed into digital data using signal modulation and encoding techniques. So they were adapting the two modules, assigning channels and time slots within cells, and your TDMAs create pulses uh, within earphones for speakers to identify various buzzing sounds that come from TDMAs. Basically, this is just saying that when you're within a TDMA for GSM technology, you would have buzzing sound, especially when you're within a speaker, when the phone is within a speaker. If you want to experience this, this is more of a challenge that happens within GSM. If you are making a call and your mobile unit is by a speaker, you will notice a buzzing sound, and that's one of the ways to determine that you're using a GSM that's using a TDMA. because TDM creates pulses when it's transmitting within the airwave, and when a speaker also generates a signal wave, right? So when it is set with this pulse created by TDMAs, it creates that buzzing sound for on your speakers. So you realize that that's what they say on your radio station. When you're making a call to a radio station, you shouldn't be near the radio device itself because the speakers are gonna more or less be receiving that pulses generated by the TDMA from the GSM transmission. Ideally, you need to move a bit away from the speaker or the radio device so you don't hear that buzzing sound being generated or created based on the pulses from the TDMA. GSM also factors into your 3Gs and 4Gs, and these are purely digital transmissions. They adapt pure digital transmissions. They do not use TDMA techniques for transmission, but instead they use a much wider, uh, uh, a much dynamic approach to handling signaling access or division or multiple access approach. So keep that in mind. The 3Gs and 4G GSMs are generally not using the TDMS anymore, TDMS techniques anymore. So hence these days, newer handsets, newer uh, technologies within the 3G and 4G or 5G networks, you don't experience that much of the buzzing sound anymore because they're no more using the TDMAs techniques for handling transmissions anymore. But they've been much more improved and enhanced these days using different methods of signal modulation, I guess. Some challenges that you might find within going back to code division multiple access, some challenges that might come up is self-jamming. So here we're going to look at some of the challenges that comes with some of these uh, uh, modes of handling uh, transmission within cellular networks. So within the code division multiple access, we have self-jamming. That is, unless all mobile users are perfectly synchronized, arriving transmissions from multiple users will not be perfectly aligned on a chip boundary. So a self-jamming is usually what happens with self-jamming within a CDMA is when mobile units are now well synchronized, especially using the right code of transmission within a given medium, then if the informations that are being transferred are well synchronized, then arriving transmission or codes from multiple users might not be perfectly aligned, and that usually creates a self-jam. So even though codes embedded in the transmission are quite unique, uh, there's also challenges that comes with that approach, especially when the timing is not synchronized properly. So usually when synchronization is not well effectively achieved within transmission for multiple users within a CDMA, then you'd have self-jamming. So at every given point in time, for you to avoid within for you to avoid self-jamming within um, PDMA, you'd have to make sure that the devices are in sync. Well, a leeway for two frequency bands to not create interference. If you remember back in earlier stages of this course, we're doing data communication one. We talked about band guards, which were to create more like a lane way to avoid crosstalks as well as interferences. So if we had distinction between these two levels of division multiple access, then time frequency guard bands are quite irrespective in terms of how signal is received, orthogonally or not, within nearby systems. So in other words, they don't create much distinctions, and that's what results in what you consider as self-jamming. Other issue is near-far problems. Signals are closer to receivers, and as compared to, or in terms of actual distance between two transmitting mobile units. So in a sense, when near far problem is established or it's encountered, it basically just means that you probably hear you be on a phone with somebody, and the person sounds like they're far away, even though they might be within a given radius that's reasonable, not extremely far away. You notice that they're a bit far away from you. You can just hear it from the communication that the signal sounds like it's far away, or the person sounds like it's far away, and that's usually what's considered as near far problem with code division multiple access. So you have signal closer uh, to receivers are perceived with less attenuation than signal that actually further away. And given lack of complete orthogonality, transmissions from more remote mobile units may be more difficult to recover for some of these issues, especially when they are not very orthogonally connected. So orthogonally here is the key essence in terms of how CDMA is able to it's able to synchronize or resynchronize transmissions that are received from each side, either from the transmitting end or from the receiving end. For the very moment they are not in synchronized, and orthogonally you have issues within the transmission. That's when you start having problems like self-jamming and near-far transmission. Okay, so keep that in mind. Synchronization is essential to avoid incomplete orthogonality within CDMAs. So generally, these are some of the key challenges that you have. GSM does have its own challenges, but generally, it's not as noticeable as you would identify within CDMA. But over time, over the years, some of these challenges, self-jamming and NEFA, have been well improved with different uh, division, multiple access, multiplexing technologies that have addressed a number of these issues. I doubt if today you're going to be dealing with self-jamming and near-far problems when using CDMAs. Like I said, the technologies have advanced over the years. They've put in enough well-structured algorithms with error controls and other rules of signaling implementation that have well addressed some of these issues. So these days, when you're on some of these technologies for signal multiplexing, you don't really notice them at all. Okay, and they're bound to improve over time with much more elaborate integrated algorithms and integrated circuitry boards for managing signal that we transmit over various devices and various mediums. Okay, so that should pretty much handle most of our uh, cellular wireless network. Obviously, there are a bunch of other information that you can read up on within the textbook, which I recommend. Obviously, the recommendation for this course is to also read the textbook because we can't capture everything in slides. So to get much more inverse or much more adapt to other key concept within the topic, we recommend you read the book and other materials that can enhance your understanding and knowledge of what cellular network is all about. So on that note, we're gonna end it over here, and all of the materials covered within the slides can be found in obviously recommended textbook within chapter 14.1 to 4. So on that note, we end the this lecture on this topic.